You haven't really done much, right? Okay. So I'm going to give you hints for finding domain. Now remember, domain is it X or Y? X. Domain is X. So really, when you're finding domain, your initial instinct should be like, it's going to be all real numbers. That's your initial instinct. So we're going to say all real numbers except, and then there's going to be certain scenarios that we have to be aware of. So generally speaking, our domain is all real numbers except for some certain scenarios. The first scenario is going to be when there's some number over X. Do you guys all know that hashtag is number sign, right? That represents number. All right, so if you have some number over X, that's a red flag. Why is this a red flag? Because remember, our domain is X, right? But if the X is in the denominator, what number can X not be in the denominator? 0, exactly. It can't be 0. So in this scenario, it's all real numbers except if we have an X in the denominator. In this scenario, X cannot equal 0. And we're going to do problems so you'll see how we'll write things down. So that's the first red flag, when you see an X in the denominator. The second red flag is if you have a radical and X is under that radical. Why? X can be a fraction, X can be a whole number, that's all good. But if I put this type of number underneath a radical, I end up getting an imaginary number. Does anybody know what number under a radical will make it imaginary? Do you remember? 1? Nope, square root of 1 is 1. 1 times 1 is 1. Anybody know? What kinds of numbers are we not allowed to have under radicals? Negative. Negative numbers, right? Do you guys remember I from last year? So like if you had the negative root of, the root of negative 25, wasn't that 5i? Yes, we remember a little bit? Yeah, okay. So we don't want imaginary because imaginary aren't real numbers. We can't graph imaginary numbers. So in this scenario, we know that X, whatever's inside my radical, has to be greater than or equal to 0. Can it be 0? Is 0 allowed? Absolutely. Square root of 0 is 0. The only thing we're not allowed to have is negatives under the radical. Everything else is allowed underneath the radical. All right, and then the third red flag is going to be when you have some number in the numerator, but not only do you have an X in the denominator, but now you have a radical and an X in the denominator. So because it's a radical and a variable in the denominator, this denominator not only, it can't be 0, but it also can't be negative either, right? Because it's in the radical. So it can't be 0 and it can't be negative. So in this scenario, X is just greater than 0. It can't be equal to 0 like in the top one. It has to be greater than 0 because if it were equal to 0, the square root of 0 is 0, which makes it undefined. Any questions on any of these red flags, these 3 red flags? If it doesn't fall under one of these red flags, what do we assume the domain is going to be? All real numbers, okay? So if it doesn't fall under one of these red flags, the domain will be all real numbers. All right, let's try some problems. Okay, we want to find the domain and range. Are we there yet for range? I don't think we're there yet for range. I think we're just finding the domain, honestly. Yeah, today's just domain, no range, sorry. Find the domain. Okay, first one. Y equals the root of 2x plus 1. All right, which red flag does this fall under? Which red flag does this fall under? One, two, or three? Good. Two. This falls under the second red flag, right? And what do we know? We know that not just the x, that whole 2x plus 1 has to be greater than or equal to 0. Because if this whole 2x plus 1 ends up being a negative number, then we have an imaginary outcome. So what we want to do to find the domain, you are going to take the whole, where is it? The whole expression underneath the radical. And you're going to say, okay, well, this whole expression has to be greater than or equal to 0. And then we solve this. We solve inequalities just like we solve equations. So what we're going to do first is subtract the 1. And then we're going to have 2x is greater than or equal to negative 1. And then we divide by 2. So x will have to be greater than or equal to negative a half. All right, there's two different ways to represent domain. The first way I'm going to show you is called set notation. So in set notation, what you do is you do squiggly brackets. And we're finding the domain, right? So it was the x. So you put the variable that you were using, so x, and then you put sort of a slash. That means such that. And then you write the inequality. What do we know? X has to be greater than negative a half. So x has to be greater than negative a half. That's called set notation. There's another notation. The other notation is called interval notation. Okay, and in interval notation, you sort of have to figure out where this is going to. So basically, if x has to be greater than or equal to negative a half, do we agree that the smallest number it could be is negative a half? Yeah. Because it's equal to, can it be negative a half? Yes. If it was not equal to, then it couldn't include negative a half. But because it's greater than or equal to, the smallest number is negative a half. So in interval notation, you write the smallest number it could possibly be first. So that's negative a half. And if that number is included in it, you put a square bracket. If that number is not included in it, you put a rounded parenthesis. So because negative a half can be part of this domain, we put a square bracket. Then you put a comma, and then you go to the largest number that it could be part of this. So when it says x is greater than or equal to negative a half, is it giving us an end point, or is it saying as long as it's bigger, it could just keep going, you're fine? As long as it's bigger, you're fine. So how do we represent something that just keeps getting bigger but never ends? Infinity. Can you ever reach infinity? No. So could we ever use a square bracket on infinity? No. We have to use a rounded parenthesis. What's up, Nico?
Should I write this down, or just different ways to do this?
You need to know both ways. You need to know both ways. You might remember it from Algebra 2, so then you don't have to. Right. So for interval notation, we're going to do smallest first, and then it's always the largest after that. So I sort of want to show you how this looks on Desmos, but the problem is if I go to Desmos, I think